So this is a 4 wire Wheatstone bridge amplifier module called an NAU7802. Lots of bits, lots of sensitivity, used for lots of things. These are used for scales and weighing and measuring bend, and so they're used for all sorts. So they're very handy. So if we go to Grove sensors, oh, it's 24 bits as well. It's actually 23 bits because it's got a minus. So yeah, let's just run him. This isn't calibrated. There are extra bits in here to do offsets and calibration. I haven't implemented any of that, but it's just a matter of filling the registers up. Read the manual, of which is linked, and you will see how to do it, or I might do it one day. It's got programmable gain. I don't know what the LDO voltage is, but I set it to the voltage of the input power. I assume that's some sort of calibration. I ought to look it up really. And it's got a programmable sample rate, so it goes up to 320 samples per second. All of that is good. So what happens is it sets a flag when it's got a new measurement, so cycle ready. So what you do is you poll that flag and then bring in the value, and it works quite well. So let's have a look. So you can see it's sitting there being a bit noisy. If we bend it the other way perhaps. Oh yeah, bend it that way. Yeah, so you can press it, and then we can change the sample rate. Oh, now it's going fast. You see it's getting a bit more raggedy in its output. I presume it's got some onboard sort of smoothing, but yeah, very useful for censoring stuff up, I would imagine. You can see the little cycle ready light flickering. That's just saying I've got a new reading. So where it goes flat, it's actually, don't know what it's doing really, but anyway, there's probably a bit of noise in this. It was a £2 sensor. And the board itself is remarkably cheap. I paid £2.60 for it. It's an Adafruit design, but I got it from AliExpress. And you'll notice that there's a quick connector, which is it's like a 1-to-1 connection. So I've still got my I2C hacking pins on this one, but the quick connector to I2C, I've included all the drawings. So if we look in here at what the block diagram is doing, we initialize as per usual. We then set it up to run, essentially. So this is its normal run state. So this is just a flag. In here we just convert these flags into a byte, and that gets sent off. We also convert these into bytes, and they get sent off into a register. Let me have a quick look. Boop. As you can see, I'm just converting stuff into bytes. There's a lot of other bits and bobs in here that I'm not doing anything with currently, but they are there to be used if people want to use them. I can only make them operational. I haven't got time to make them completely correct as per the data sheets. Yeah, and what it looks for, it comes in here on the timeout and it says, is the cycle ready? And if it is, it chucks it on the graph. That's literally it. So it whips around as fast as you like. And what I'm doing is modifying the timeout, so it's not the most accurate way of doing things, but it's alright for now. So on the data rate, I'm just approximating a time where it will then just wait and tick over. So I'm sure you could do something a bit more accurate if you wanted to. And that is that one.